Well, that's over the weekend.
So I need this guy showed a microphone.
Technically, you don't need it. You can leave it on this one. It will still pick it up.
Oh, well.
That's it,
What do you want to do with that? So really quick, if you didn't hear, there's a zip file that I just slacked everyone on the general channel. If you want to grab that, you just need a text editor and Chrome. There's no live reload, no NPM, nothing fancy. Yes, maybe. As long as it supports some of the ECMA 6, I use ECMA 6.
Oh, okay.
Turns out when you're converting TypeScript back to JavaScript, I forgot about some things. But it works in Chrome, so that's great.
Did you put it on Teams so Chris can get it?
No.
Or I'm on that.
So Aaron and I, we're going to tag team this one. We're going to talk a little bit about D3.js and some drawing with SVG and Canvas. So he's going to do a lot of the Canvas stuff. I'm going to do the D3. So D3 is just a library that makes it easy to do data visualization and drawing. It lets you do it with either SVG or Canvas. And then Canvas is just an HTML5 standard for rendering things. So the goal is that we're going to give you guys some basic skills to draw things with that would be a little more advanced with HTML or SVG. So a little more about D3. So this library was created by a former USU graduate while he worked for the New York Times on data visualization. So that's like, the cool thing about, little shout out to USU. Its goal is to make data visualizations easier. So there's a ton of functions for calculating different things so that you can just give it data and it spits it back out. As Devin puts it though, where's Devin?
So he's not
here.
I know.
He calls it jQuery for drawing, which he's partially right about, but I kind of disagree. It does more than just draw, so and it can use either Canvas or SVGs. So on that, so I was going to keep this talking really quick about when should you use Canvas and when should you use SVG. So this came from Microsoft. They did a little study on the two, and the big thing that they came down to is SVGs work better if you want really high fidelity graphics and you want to print, because you can easily print the SVG stuff. Canvas works better if you want a lot of things going on, so you need high performance. So basically, if you look at this chart over here, for Canvas, as you get more objects, so I'm looking on this side, the more objects you have in Canvas, you don't really go up in time to render. But the more items you have in an SVG, your time goes up. So if you have a ton of things, you probably don't want to use an SVG. If your screen is huge, though, Canvas takes longer to render versus SVG. So there's kind of a trade-off there. Big thing, static images or high fidelity SVG, animations, games, things like that, Canvas. Okay, enough with the slides for a minute. So really quick, I want to show you a couple of things that you can do in D3. How do I get rid of this thing? Oh, can I still scroll?
Yeah.
So this is kind of some of the stuff to show off some of the things that it does for you. So, it kind of has all the mathematical smarts to figure out different things like force, propagation. There's all sorts of demos. This one's kind of a funky one. This one will mess with your mind.
That's what we need.
So.
We got a lot of snacks.
This is D3 or this is Canvas? Sorry.
This is D3.
D3, right?
And some of these are using Canvases, some are SVGs, by the way.
Yeah, so that one that I just showed you, that was done in Canvas. This one looks like SVG. They also have some cool tools for helping with dragging and moving elements. So this is, I think, called a Veroni diagram, which gives you approximations between circles. So if you get close to the circle, you can still move it. So if you ever want to do something where it's like, I don't want them to have to click, I just want them to get close, this kind of builds out a clicking area, and you could hide the lines, and then they can click and move things around. But a lot of complex math that I don't want to figure out going on there. So let's look at. So if you look in your folder, you have a circles. So there's a circles folder, and then there's an index.html. If you open that, that's what we're going to look at. So this one, I'm going to go through what the code does. So this just lets you draw circles and move them around. So we'll walk through the code real quick. The next one, the donut chart, we'll actually code that together. So let's see. Is it okay if I make that just a little bit smaller?
They go off the side. How do I?
How do you get them back?
I don't know.
First we move it.
Well, I'm not good about the code while I was playing the game.
So a couple of things that are going on here. So line 1, I've got d3.select. So here I'm selecting my SVG element. This is where it feels very jQuery. And then I'm just going to get some things off of it really quick. I'm going to get the width, the height, and then I'm just going to store off a radius so that I've got it for later. So then I'm going to generate my circles. So D3 has some functions for creating a range of random data. So I can do D3 range 20, and then I'm going to map that to X and Y using random. So I can kind of just get a spread of random places from my original circles. So the D3 also has some color schemes. This is actually quite nice. If you're doing anything graphing-wise or where you have an indeterminate number of items, they have color ranges. So this one's a 20, but if you go beyond 20, so if you go beyond 20, like we hit 21, you're going to start repeating colors. But the idea being that most things like line charts, bar charts, they be far enough away from each other that you can delineate them, or you just pick a bigger scheme category, and then it generates colors for you. And you can pre-generate your own colors. So here's where the D3 magic is. So I'm taking my SVG element and I'm selecting all circles. So at this point, I technically don't have any circles. I just have an empty SVG element, but I'm going to select all my circles. And the key there is that this allows this code to be re-executed multiple times. So now I'm going to do .data circles. So what this does is it's going to kind of map my data, my array of circles, to these circle elements that I've selected. And it knows when one of those is new or existing. So now, and this is, I'm not a huge fan of some of their syntax, I'm going to enter into that data. In my mind, that's just more like a for each. So everything I do after that enter is going to happen on every single one of those data points. So now, on each one of those data points, I'm going to append a circle into my SVG. And that circle, I'm going to give an attribute of CX, which is the X value, CY, which is my Y value, a radius, a fill, which is going to color, and then, so at this point now I'm drawing everything. So now I'm going to also do this D3 drag. So so call is going to execute this function on all of those SVG elements. But I'm going to generate the function that I want to call. So I'm going to do d3.drag, and I have on start, on drag, and on end. And I specify those functions. So for drag started, I'm going to do d3.select. So on these functions, this that gets given to you, which is kind of weird, I just pass it in as a parameter, is the element. So in my D3 chart, I'm going to select the SVG element that it gave me. And on this one, I'm going to raise it to the top, and then I'm going to give it the class active. So if you look at this, you'll see when I click on that brown one, it gets bumped all the way to the top. So then there's also the drag function, and it does the same exact thing, but it just modifies the X and the Y coordinates based on the event X and Y coordinates. And then drag end removes the class. So one of the cool things about using SVGs is you can style SVG elements. So as opposed to Canvas, which you have to do all of the styling manually, SVGs, they're just tags. It's just an extension of HTML. So anything you can, in the same way you can style stuff, you can do classes, objects, etc. The definitions for styling are different for SVGs, so stroke width. So now you can see when I click on one, it's getting that active class, and that's why it gets that stroke around it. So if we look, that bar thing is really in the wrong place. So we look at the code or whatever it calls, the HTML that's generated. I have my SVG body, and I've just set a whole bunch of circle elements in there and given them all the right things. And if we move this to the side, you can see if I can get one that's high enough up. You can see it adding the class active on that lower one, and then it goes away. And if you're noticing, like when I click on one, it moves them around. That raising moves that one to the bottom. So things are drawn in the order, so the bottom one is going to be drawn last, so it'll be on top of everything. So this is what we're going to build together. So I don't know if this will actually ever get used, but I built this for issue tracking. So kind of a combo control here. So
It'll totally get used. Wes has already asked me.
Okay, that's good. So this is both a control and a visualization. So the idea being is you get your pie chart that shows how much of a different data point takes up of a whole, but also now I can select something, and then in the application the idea is that something over here changes. So I've got a control and a data visualization.
What do you call that cool little controller?
The donuts? Because I don't want to call it the other one. So if you want to open your app, the app.js under donut, we'll work through that. If you want to cheat, you can just grab the original.js. Cheaters. So the first thing that you'll want to do, I probably should have just done this, but uncomment out the render pi function so that it actually works. So some things that I'm doing for us, I'm getting some of the D3 stuff set up, getting some data, the color all set up. I'm also calculating my arc parameters. So all of my donut pieces, they need to have a radius for the inner and the outer portion of the arc. I'm calculating all of that here so that we don't have to do it later. You can skip the render marker, we're not going to go over that, but D3 can render or help you draw anything. So I wanted to draw that marker, but I had to basically just calculate it myself, so I figured out the math to figure out where all my points should be, and then I had to generate a nice beautiful string.
All the points of what, Charles?
The marker, this guy. So I had to calculate where my corners would be, where they round, when I get to this point, and then I go over. That was fun.
I'm surprised it doesn't have a way to do that.
So you can draw a square, but it doesn't handle like a...
Your cool shape.
Yeah, my cool shape.
Cool layout.
So in RenderPy, the first thing that we need to do is we need to calculate our wedges. So you don't need to bust out your geometry here. It does this for us. So it's var wedges equals d3.py dot value. And then I'm going to do a function. So this is a mapping function. So this is just saying, in order to get my value out of whatever data I'm going to get, this is how you're going to get it. Dot, oh sorry, not dot. Then I'm going to call this function that it returns, and I'm going to give it my data. So dc.data. So now this wedges will be an array of pre-calculated, I think it's radians, I think is what they use for the drawing. So now let's get our paths. So let's get our existing paths first, which there aren't going to be any. So existing paths equals dc.arc group.
DC.
donut control. It's basically, DC is kind of my this. So if, but since I'm not using TypeScript, my this gets screwed up, so I alias this to DC. Okay. So dc.artgroup.select all, and then I'm going to select all and all things with the class .art, which I have none of at the moment. And I'm going to join it with my data, which is my wedges. Now let's get our new paths. Equals existing paths dot enter dot append. So here what I'm going to do is I'm going to, for every data point that I have, I'm going to append a G element, which is a group in SVG. And I'm going to give it the attribute class dot arc. So now I've basically just created those arcs. Now I'm not drawing anything yet. I just have. So I put a semicolon there. Yes. Oh, I do want a semicolon. So I've now created all of my groups for every piece of data element. Now I want to actually start putting some drawing down there. So for my new paths, I want to append for each one of them a path. So path is just an SVG element that basically defines points and arcs between, and the D3.py gives us that string for us. We don't have to figure it out. So the attribute for the D, which is that weird path, it's going to be a function, and that function is going to return dc.arc data. So what's happening here, hold on, let me get rid of this, is, so I'm going to, for all my paths, I'm going to set the attribute D to whatever this function returns, and dc.arc is an arc that I defined earlier. So it's going to take and convert my wedges, which are radians of a pi, and give me an actual two-dimensional object back. So if we save, oh, hold on. I got to take out the cheater mode. So at this point, we have this. So we've now successfully drawn a circle, and you can kind of see the wedges in there. And guys, let me know if I'm going too fast. I don't want to take all of his time. So we're going to do a couple other things really quick. We're going to style, give it a fill. This is datum. And we're going to return the color. So it's dc.color, datum, data.id. So now if you look at that really quick, we know how colors. Sorry. So what do you guys want to do next? We got this, we got drawing. So in order, what we need to do is we need to make some animations. We need to make it pop out when you click on things. We also need, so.
I love animations.
Yeah.
Okay, well we have to do flipping first. So because we gotta rotate something. So let's do, so we're gonna do on, click. By the way, so far this is all chain on this new path, so there's no semicolons if you're kind of wondering why something's not working.
I was.
So on click, I want to get my data element, and I'm just going to mark it selected equals true. So if I do this, now every time you click on something, everything's going to be true, and I need to take off the previous one. I realize there are other ways to do this, but this is the quick and easy way for showing everyone. So just for each on my data, j.selected is false, and I need to do this before, so I don't mark that one out. So clear out all the selected, select the one that you checked. So at this point, it's not doing anything. So we can click. I'm assuming my data in the background is changing, but I haven't actually told it to do anything. Yep. So now we'll do the rotation. So if you have the cheater app, or just open it and copy this. This is a lot of typing, and I'll just walk through it because there's some math there. So if you're looking in the cheater, it's lines 140 to 142. So after you save that and refresh, you'll notice your pie rotates once, but it doesn't rotate when we click.
Right.
So to make it rotate when we click, we just need to tell the D3 to re-render what we've done so it can give everything the new rotation, it can draw everything. So we probably want to do that on click. So here in the on click, just do a render pie. So now, if we refresh, now when we click, we have. So what's going on in the rotation really quick? I'm finding my wedge that I want to rotate to, and then I'm calculating how many degrees in my pie I need to rotate for that. So that's the math that took me a little while to figure out when I did this the first time, so that it was centered here. So don't worry about that. And then the way we do the rotation is we just do a transform on the SVG element. So unfortunately, the transform string has to be cumulative. So previously, I'd set a translate on there. So I have to recalculate that translate again. Because if I just set rotate, it would wipe out my translate. So I have my translate, and then I've got my rotation delta. And it's comma 0, because you can do 3-dimensional SVG. And we aren't going there. So.
Next one.
Yeah, next conference, exactly. So next, so if you remember when you clicked on one, it got a little bit bigger. So we'll go ahead and do that. So here, we have to do this on the existing paths instead of our new paths. Because at this point, when we're entering our drawing, we've already got our stuff there. So we're going to do dot attribute, or attribute D data. Let me know if I'm taking too much time.
Yeah, you're good.
And I'm going to return the
Extra slash. Why not?
Oh, thank you. DC dot selected arc datum. So this will work, but it's not finished. But I'll show you what it does now. So now, as I select them, hopefully. Oh no, what did I break? Oh, there. Okay, why is that not? Oh, I missed a line. We need to go into enter into our path. So right now, what I was just doing was just putting that attribute on that group. So I need to do dot select. Actually, hold on, just 1 second. Terminate line 93 if you're on the same line as me, and then do existing paths dot select. And now select the path. There we go. Coding live is great. There we go. All of them got big. If you missed that. So we just need to do an if statement here. So if datum.data.selected is true, then we're going to use the bigger arc. Otherwise, let's just use dc.arc datum. So now they get bigger just on the ones that are selected. One thing to note on that on the animation, sorry, I forgot to show this. Animations are generally handled for you. So all I had to do to animate that was just do a dot transition, and then D3 will just transition from A to B for me. You can do some more fancy stuff with transition. You can also pass in an easing function if you want to ease in, ease out, however you want to do it. But it does figure out like the shortest path. So if I click this one, it rotates that way. If I click this
You
one,
force it to rotate in the way.
if you do your animation, but transition will always just find the shortest path to get it to the other state. So. So something else that we had on the other one is that we had a drop shadow on the selected one. So again, we're going to come into the existing path because at this point our paths are already set up, and I'm going to do a filter. So SVGs kind of work with functions. So if you look at my donut.index.html, I've got this filter function that is going to do some magic for me. So I'll do style.filter. Datum, come on. And if my datum.data.selected, I'm going to return, and I'm going to return this weird string that's going to tell it that I want it to use my function. I hope this works. And now that, if you can see, has a little drop shadow on it. Last thing I want to do really quick is the hover. So back on the new paths, we're going to do .on hover. Sorry, not hover, mouse over. Mouse enter. So here I have to be a little bit more careful. So here I can't use the fat arrow function because I want to get the list that mouse enter is going to give me, and if I do a fat arrow function, I get the wrong lists. So on mouse enter, D3.select. So here, this event is going to give me the SVG element that I selected as this. So that's why I wanted to keep this. So doing D3.select this gives me that element. And now I'm just going to modify its attribute for D to be datum D3.hoverArc datum. And now when I mouse over, they get bigger. And they're not getting smaller because, again, and I'm not going to do this because I'm going to let Aaron have the time, I would need to do a mouse exit, and I would need to do the same thing, but just call my other arc, so it returns it back to its regular size. So basically just look like this. Oops.
Mouse lead.
Yeah, mouse lead. And now I'm just going to do arc instead of hover arc. So when the mouse enters, I alter it to be the big one. When the mouse leaves, I reset it back. And then it looks like this.
Cool.
Any questions?
Was the math the hardest part? Or finding the right?
So when I did this, the hardest part was figuring out this first bit. Like understanding what's going on, sorry, not here, here was kind of confusing to me. I didn't really grasp what the enter and what, like if that had been for each, that would have been a lot more clear to me that everything was happening. So that was the first thing. And then, you know, figuring out the math on some of these things, mostly the rotation, getting all of my angles so that it's centered is probably the hardest part. So, okay, I'll turn the time over to Aaron for his part. Oh, hold on, no, we have slides. I'll let you walk through these slides though.
Okay, so next we're going to be going over just plain vanilla canvases. So D3, you can use canvases, and it wraps a lot of this functionality that I'm about to show you, makes some things a lot easier, but there's some things that it's still good to just use plain old vanilla canvases, and I'll go into some of those in just a bit. So native canvas is better for games. We tried to do some stuff with Flappy Bird using D3, and it wasn't working out so well. So it's great for data visualization, not so great for games and some other animations, depending on what you're doing. Complex user components and non-data visualizations. Like I said, D3 is great for data visualizations. There's even a lot of examples on their website. It's pretty plug and play, but certain things, it's still good to use just plain old Canvas. So some basics, Canvas is just an HTML, it's just a Canvas HTML5 element. I'll show you how. So we're going to be doing some animations, and we're doing a game. So we're going to need to update our canvas every frame. If you're not doing animations, it's it's not something that you're going to be doing. And when you do render a new frame, typically you'll redraw the entire canvas, or else you'll have, depending on how you do it, you're going to have some leftover artifacts from the last time you re-rendered. So typically, during an animation, you'll clear everything out and re-render. So in our project, we have, and I'm probably going to want to switch over to my machine to broadcast. We have Flappy Bird using just vanilla canvases, just JavaScript, nothing fancy. If any of you don't know what Flappy Bird is, it was a really stupid app that someone made, and they made a lot of money. So you too can make a lot of money with this. So.
I think one time the guy with Flappy Bird was making $500,000 a day.
Yeah, and it was a free app, and so that was just ad revenue. Like,
It's ridiculous.
so I want to be in the camera, but I also don't like the sun in my face.
You don't have to do the camera. It's okay.
Okay. Well, then I'm moving. That's all.
Yeah.
Can I get rid of that? Okay. Let's hop back over into this. Okay. So first thing that we're going to want to do is in the root of our project, we have just our app.js and our HTML file. I don't know if I'm still in donut. HTML. One thing that we're probably going to have to add is in the HTML, we need to go ahead and throw the canvas back in.
So edited the wrong HTML file.
Yeah, so we have some SVG stuff. In fact, we can probably remove all that SVG stuff and then just have our canvas. Set the width to 640 and height to 480. I don't know if it matters. I just haven't tested it. I don't know if the math that this guy used is dependent on that or if he actually checks the canvas dimensions when he's rendering stuff. Okay, just jumping into here, like I said, so we're doing a game here, so we're going to want to update our canvas every frame. And one of the recommended ways to do that is we have window request animation frame, and then we're just passing ourselves into it. Our function to be called recursively, and this is telling the browser that we want to call our draw function before the next repaint. Typically, this is about 60 frames a second, I think is what I was reading, but it could be faster or slower depending on your machine and what browser you're using. One way to lock the frame rate down, you can check the time that's passed since the last animation frame, and essentially don't redraw if it's too quick, and so you can lock yourself into a certain frame rate, which I believe in here we set it to about 30 FPS is what we do. So we just have an FPS counter. We take this guy's taking our date, and then he's comparing it against that, and only redrawing right here. Again, we're doing some math to draw against that, so we're not going to go faster than 30 frames a second. Now, that doesn't count if you're going slower than that, though. So if you're draw function is taking a little too much time, it'll slow things down. You're going to get a lower frame rate. But this at least makes it so you're not speeding up at 100 frames a second and your game's running way too fast. Okay, so what I'm going to do is just step through this. There's a lot of math here that I don't want to figure out with everyone, so I'm just going to kind of uncomment the game slowly and kind of explain what's happening here. So we're redrawing every frame. Typically, it's good practice to clear out your canvas before you do your next redraw, or else you can get some weird stuff from the last time you drew. See. Next step here is we're going to draw our background. So if we take a look at this guy, you can just kind of be uncommenting this as we go and play around with it while I talk about it. So what we have here is we have a couple of images which we're drawing, and we have an X value and a Y value on it. So if we look at our background, so we're drawing these guys. So if we take a look at what's going on here, when we create a new background, this is essentially acting like a class. So when we have our background, we set our X and Y, and then after we draw these, we're going to call the move function, which is essentially just going to shift our X values over. And so we're going to kind of have a panning background that's going to happen over time, which we'll see, which in fact, I think, draw background. If we save it just there, we should be able to see what's going on. There we go. So the reason there's two images here is he has essentially two seamless images, and so we're kind of panning through, and you're seeing the other one, and then he just replaces and keeps going to make it seem like we have this endless scrolling city going on. If I wanted to do this myself, because there's a bunch of, you can see there's the buildings in the background, and we can actually have these scrolling at different speeds to kind of get like a parallaxing thing to kind of make it look a little 3D. That would be cool, but all right. So now it's a little boring at the moment, so.
I have a quick question for you.
Yeah.
Most of the time when you're doing games, you're going to render two screens and then just switch them out back and forth. Is that what this is doing? Or is
You mean for that background, like that seamless?
Yeah, so well, not for the background, but you'll render a screen and then you'll change your pointer to the screen.
So you render two frames.
Yeah,
Okay.
and then you just replace it, or is when you clear, is that actually clearing the?
It's clearing the whole thing, yeah. So we're wiping the whole frame out and then just redrawing every time.
So the way Canvas works, if you put a column set up there, you have a white screen in it. So it's drawing it as you see it. So,
Yes.
Unity might do some of that stuff to point you out for things.
Yeah, this is not doing that. This request animation frame, the browser will wait for your draw function to finish before it repaints. So we're going to go and render everything, and then it's going to go ahead and show it. So that's why you're not seeing it clear out and redraw every time. It will wait for that to finish. But yeah, it's just one frame. We're not rendering another one and then swapping it in. Okay, so right now let's do we're going to do a little bit of a kind of a menu. So drawing text in Canvases is a little interesting. So if you're trying to render text inside of an element, let's say we have a button and we're going to put some text in there. It doesn't know that it's inside of a button. It's just going to render that in Canvas. So it'll bleed over. It doesn't wrap. You don't have any of that stuff you would if you were to render it in DOM. So like if you're doing something in D3 with SVGs, it's a lot easier to do stuff like that because you can just wrap the text. In this case, we're just going to have a little flashing menu that says click to start game. and it's going to flash, and what we're going to do is before you draw anything in canvases, you'll set a stroke style or a fill style to kind of say what, it's essentially how you're going to style what you're about to render. Your stroke is the outline of whatever image you're about to draw. Fill is everything inside of that. So what we're doing here is you can pass in all sorts of things with this. You can pass in RGBs, RGBAs, which is what we're doing right now. You can just pass in a color like red, blue, green. You can do a hex, hex code for your color. So what we're doing here is every frame we're calling our text alpha get. We have a get and a fluctuate. So if we look at our text alpha function, we're setting our alpha to 1, and then essentially we're just stepping it up and down every frame. And so it's going to drop down. Once it's 0, it's going to start scaling back up. And so that's how we're going to get our flashing text here. Once again, in Canvas, you can't just style things like you can with SVGs. So this would be a lot easier because you can just set a transparency on it. So if we look at this now, let's click that. We should see our click to start game, and it's going to adjust its alpha every frame until it gets to 1, and it's going to drop back down to 0. So that's neat. And then right now, we're not actually playing anything right now, so I'm actually going to step down. It says step 7, but we're doing it right now. So in order for this to work, basically we're just adding a click event listener onto the entire canvas. So anywhere we click here, it'll start playing our game, and then that's what we're going to use for the actual control of the game. You're just going to click. So let's go ahead and draw our enemies. So our enemies in Flappy Bird are essentially obstacles that you're trying to avoid. So as we click, our little bird is going to flap, and we're going to try and avoid those guys. And let's see how draw enemies is working. So draw enemies is working similar to how we do our alpha. Our enemies have a move function that essentially every frame we're just going to move their values, their x coordinates. And I'm not going to go too much into that because I want to talk about draw player. So our player image, if we open this up, it's an image. So essentially what we have here is 3 frames. It's a single image. We have kind of our wing up, middle wing, down wing, and as we play through these, it's going to give us our animation. When drawing images, you can pass in some optional parameters to say, not only I want to draw this image, but you can specify where on the image you want to draw. So we're actually drawing coordinates on the image, and we're only rendering that frame, essentially. And so as we go through this, we're going to render that, and it's going to appear like we're actually flapping. Fall has some math that I don't want to go over. I'm going to save that out, and then I think this is going to work just fine. Yes. So now with all of that uncommented, we should be able to click, and then we have our little bird. He's flapping. Like I said, it's the same image. We're just choosing which portion to render. And then eventually I'm going to hit something and lose control. And start over. Josh has the high score of 2, if anyone can beat that.
Barely. I got 3. Oh, man. Loser.
And then to draw our score, we already kind of talked about drawing text. Fill style, like I said, you can do it all sorts of different colors for here. RGB, you can just say black, white, red, blue, whatever. So for drawing shapes, you can do stroke and fill. So there's stroke rect, fill rect. In fact, actually, let me pull up our rendering context. There's all sorts of things if you need to draw arcs, lines. You can draw complex shapes by doing, you can start a point, you can do line 2, and then fill those shapes in if you want. Let's do a quick, I think we have time to do a little hands-on thing. So let's do, right now, you can click anywhere on our canvas and we can start our game. Let's try creating a button on the page, and then you have to click that to start the game instead. In D3, it gives you a lot of useful tools for clicking on specific things in canvases. SVGs are super simple because it's a separate element in the DOM, so you can just throw a click event on that. Canvases, it's not so simple. So what we'll do, and you guys can kind of work on this if you want ahead, or just, I'm going to give you a little snippet of code that helps with this. So on our event listener, on our canvas, what I'm going to do is we're going to grab that click event and pass it in here, and then we're going to grab the essentially the dimensions of our canvas, and then figure out from that click event where we clicked relative to the canvas. So we actually get our XY coordinates for the canvas. And then, let's see, we have here game is not playing. We're going to go ahead and set that up. Let's do an extra thing here. Well, we're going to need a button first. So in our draw, let's go ahead and create a button here. In fact, I just have a little guy right here that I'm going to make. So you can set this to whatever you want to. We can just make that white, and then we'll go ahead and fill a button there. So this isn't really a button, just a square that we're going to render up there. Actually, probably put it up here because we don't want it to be displaying all the time, only when we're in that kind of beginning game state. So now we have a square that we're rendering. Just in the upper left is what I'm doing. Is just our XY coordinates, XY, and then how wide and tall we want it to be in pixels. So now that we have that rendering, we have our click. We know XY coordinates relative to the canvas. What we can do is we want to reset game right now if we're not playing. But let's also do a check and say, what's the name for it? So there's an is point in path. And we pass it an XY coordinate on the canvas, and it's going to say if that point is anywhere in that path that we just drew. The problem here is we don't have a path, so what we're going to have to do is, I have a little code down here. I'm not as brave as Travis.
Travis is quite brave.
I have the paper next to me. I didn't keep the thoughts.
So So what we're gonna do is we're gonna begin a path and then we're gonna start drawing a path. This isn't going to actually draw anything on the screen until, for example, I could do a fill, and then that's gonna fill in the path that I just drew there. So what we're gonna do is we're creating a path, and this is the same dimensions as that little square that I drew in the upper left. And now we're just gonna give it an extra condition that says, all right, is the XY of my click, is that in the path that I just drew here? And if so, it's on the button. So, and then probably for safety's sake, we want to do a restore, which restores our context back to the previously saved state. When I start up a path, it doesn't essentially save it or write it to canvas, like I said, until I did like a fill or I closed the path. In that case, it will save. So we can restore it and just kind of get rid of it, just so it doesn't do anything weird in the future. And this should work.
Your confidence is overwhelming.
Real confident. So now we're clicking. It's not doing anything because we're not within that, but theoretically anywhere within here should be able to click. And it should work. And we have a button now. So some of that stuff is a little tedious to do in canvases.
Should give you some sympathy for those complex things that have clickable elements all over. You don't have to do that for every
Yeah. So yeah, if you have something like that, like hover overs, you have to do, essentially you do like an on mouse move.
I think Aaron has more financial control.
I'm
I'm at 22, so
That's
Yeah, but he also.
I maximized the whole screen to fit and so the sticks are farther apart.
Oh, okay.
He's at 22.
28.
You can go all day.
Yeah. The background wasn't resized right. But
Oh, when you scale it up?
yeah.
I just,
Makes sense.
I cheated and just zoomed in. It works fine.
But it doesn't give you more width between the elements.
No, it doesn't. Nope.
This is not helping. In fact, my 9-year-old thinks I go to work all day and play video games. This isn't helping my argument. Actually do work.
My bad.
No, you're right.
You make video games.
It's different.
You make video
That's all I have for just vanilla canvases.
Cool.
So if you tried to do multiple buttons, you'd have to do a begin path, draw your rectangle, check that rectangle, clear it with the restore, and then check the next button you have to.
So what I'd probably do is I'd make like a button object, and I'd have an array of button objects with all their coordinates and widths and heights. I draw paths for all of the buttons, click, and then just kind of check, hey, is this anywhere within any of those? In fact, you wouldn't even have to really draw the path and do this pointed path. You can probably just do some math and say, is this XY coordinate within the bounds of any of these guys?
So there are multiple strategies for this on how you want to figure it out. This is an aspect because you just do this pointable path.
Yeah. In fact, in inspections, we have a big schedule tool that we have hover overs and click events on all sorts of things. And so I actually will iterate over all of those objects and say, is this in any of this? Is it in the path of any of these guys? And if so, re-render, we have a hover over thing. And if you click, then we know what element it is. So you have a button and then just call that click event that you have on the button.
It has to do it really quick.
It does it really fast, actually. Canvases are blazing fast. The fact that it's rendering a lot of these things, I don't know, I think in inspections it's running at 60, 70 frames a second on mouse move. So every time you're moving around, it's re-rendering the entire thing and you never notice.
So that is one big thing with Canvas. Canvas doesn't have clipping, so you can have things that normally, so like for example, the drawing tool, you don't have to figure out how to draw in the window. You can draw everything, but then you give it a clip, and the Canvas will smartly not draw what's outside of the clip.
Yeah.
So you don't have to do that. And SVGs don't do that, so SVGs just draw everything. That's probably one of the big reasons why they get non-performant, they get more objects that kind of.
Yeah, and with SVGs, if you have a bunch of different ones, see, they're rendered as a separate DOM element, whereas with a canvas, it's one, and you're just manipulating that essentially. But it's less performant larger because it's essentially a pixel by pixel replacement, I think is what it does. And so more pixels, less performant, whereas SVGs, it's just math that just draws the shape, so it doesn't matter how big it is.
Stone takes it a step further. He just eliminates the obstacle at the bottom. Well played.
That works. Are there any other questions about D3 canvases, SVGs versus canvases? Okay. Great. Leaving this meeting. Stop that.
Yeah, we got a break. Lunch will be here at 11. We have 2 talks at 11 full service projects, so we'll have lunch. So, be back in 10 minutes, yeah? Don't have to go to Josh, you are set. I don't know anything.